Here we need to remember both the distributive property, and on the next slide, we'll see how to multiply binomials times binomials using FOIL. Rule of thumb is that all polynomials, in order to multiply them, we'll have to take all of the terms in one polynomial and multiply it by all of the terms in the second polynomial. What are we really talking about here? So when we're looking at the distributive property, here we'd say, okay, that's a times the second polynomial, which is a binomial, b plus c. Sure, order of operations would ask us to add first, but b and c are not like terms, so we do have a workaround. We are able to go ahead and multiply. So we'll take the monomial a and multiply it by the first term in the brackets to give us ab, and then again take the monomial a, multiply it by the second term in the brackets to give us ac. And of course, those are added together. And that's because c is positive, as is b. All right, what does this look like? Well, the first thing I want to talk about when I see any of these expressions is go back to definitions and say, how many terms do I have? What am I working with here? And I'll notice that I've got two terms, minus sign between them. And I know that I need to multiply before I can add or subtract. So what distinguishing between terms and factors also allows us to do is to ensure that we're following the correct order of operations. Once you found where your terms are, you need to work within a term first before you start adding and subtracting terms, as we did on the previous slide. All right, so within this first term, what can we do? Well, we can take the 4 and multiply it by the 2x. 4 times 2x is 8x. And also take the 4 and multiply it by negative y. So we have negative 4y. So that's worked out the first term. What's the monomial for the second term? Of course, there's a 1 in front of those brackets. There's no explicit coefficient. The coefficient is 1. So we're going to take negative 1 and multiply it by 3y to give us negative 3y. We'll take that negative 1 and multiply it by x to give us negative x. And then finally, negative 1 times positive 2 is negative 2. So we've seen this before. We know that a negative side outside of the brackets has the effect of changing the sign of everything within the brackets. But it's really just an application of the distributive property. Because we're asked to simplify these expressions, it's implicit that we're now going to collect any like or similar terms. How many terms with x's do we have? We've got 8x and negative x. 8 minus 1 is 7, so we have 7x. And we have negative 4y and negative 3y. Negative 4 minus 3 is also 7, but negative 7y. And finally, negative 2. Let's go for green. All right, I want to use this example to point out a very common mistake to make. And I think it happens when we're moving a little bit too quickly. Sometimes our brains look at this and see 5 minus 2. I know what 5 minus 2 is. 5 minus 2 is 3. And then maybe you write 3 minus 4x plus y plus x. But maybe you're looking at that and saying, wait a minute. We were just talking about distributive property. And we were just talking about doing multiplication before addition and subtraction. And you'd be absolutely right. So this is not the right instinct. So I'm going to get rid of everything that we just did. And I'll try this properly. Okay, starting where we started before, with enumerating the terms, helps us to avoid that mistake. We have 3 terms here, and we have to work within terms before we can add and subtract terms. So we know that that positive 5 and the positive x on the right-hand side, we're not going to touch those yet. We haven't simplified the middle term yet. So let's do that now. So the monomial is negative 2. And we're multiplying that by positive 3 to give us negative 6. Negative 2 times negative 4x is positive 8x. And negative 2 times y is negative 2y. Squeeze that in there. So now we've done everything we possibly can. If I highlight where the terms used to be, just to take it back to how I highlighted the terms in the original statement, you can see that there's nothing else that we can simplify within this term. So now we are at the point where we should be collecting like terms, adding and subtracting like terms. I'll start in alphabetical order and then write the numerals, the numbers only at the end. So we have 8x plus x is 9x. The 2y stands out on its own, so negative 2y follows next, and 5 minus 6 is negative 1. Frankly, it's not a big deal if you write this in a different order. Perhaps you wrote it the way you saw it up here. 5 minus 6 is negative 1. Just make a bit of a cut there to indicate that this is an alternate answer. And then 8x plus x is 9x, and then maybe you encountered the 2y. This answer is fine. What you'll find if you're doing questions through MyLab is you do want to write them in alphabetical order because that's standard. And we're also usually going to write our answers so that if I had any squares here, x squared, for example, y squared, so that the highest powers are written first. So you'd have a 2x squared, for example, written before a 3x because the x squared term would come before the x term. But technically, mathematically, these two are absolutely, they are identical. But we prefer this first answer with all of the terms in alphabetical order. Okay, what happens if we don't have a monomial and a polynomial, but rather two polynomials, in this case two binomials, to multiply together? That's where we have to go back to the definition of multiplication of polynomials, or think of it as the instruction. We have to be careful to look at each term of each polynomial, so each term of each set of brackets in this case, and make sure we're multiplying everything in the first polynomial by everything in the second polynomial. So while it's not necessary to use this acronym FOIL, you may already be familiar with it, so I'll remind you that this is where we get to use it. If we've got a binomial, multiplying it by a binomial, we'll take the first two terms, the two firsts, and multiply them together. As a second step, we'll take the outside terms, so that's here the 5y and the 4, and multiply them. The I in FOIL stands for inside, so we'll take the two terms closest together, the 2 and the negative y, and then finally L is for last. We'll multiply the last two terms in each. Let's see what that actually looks like. So let's tidy this up a little bit. Now remember that this only works for two binomials. Okay, first, 5y times negative y. Don't forget your exponent rules. That gives us negative 5y squared. 5y times 4, positive 4, is positive 20y. So that's the outside. And you can also see as I draw these lines that I've now taken the 5y, one term of the first bracket, and I've multiplied it by both terms in the second bracket. There's nothing else to be done with the 5y. And I'll now focus on the second term in the first bracket, the 2. So I'll take that 2 and multiply it by the other inside number, by the first term in the second bracket. 2 times negative y is negative 2y. And then finally, the last in both brackets are positive 2 and positive 4, and multiplied those give us positive 8. What you may also notice is I've taken two terms, so two terms in this first bracket, and multiplied it by two terms. How many terms did we get? Well, in this next line, we have 4 terms. That's always going to work out. It doesn't mean that our final answer will have 4 terms, and you may notice that we have some like terms. We've got 2 terms that have y's, so I'll collect those. So our final answer is negative 5y squared. Positive 20 minus 2 is positive 18, so positive 18y. And finally, plus 8. And that's our final answer. For the second problem, there's a little bit more going on because now I've got this 2x in the way as well. So we'll recognize the x plus 4 and the x minus 3 portion as two binomials multiplied together, but now we also have a monomial out front. You can think of this problem this way. If I ask you to multiply 2 times 3 times 5, what do you get? Well, maybe you said 2 times 3 is 6, and 6 times 5 is 30, and you'd be right. Or maybe you notice that 2 times 5 is easy. 2 times 5 is 10, and 10 times 3 is 30. And we get the same answer. What this tells us is it doesn't matter what order we multiply these pieces in. What's important is we don't use anything twice. we wouldn't say 2 times 3 is 6, and 2 times 5 is 10, and 6 times 10 is 60. We've used the 2 twice, and we can't do that here. Right? Notice we've got 3 factors that we're multiplying together. Same thing here. We've got a 2x, or you can think of it as 4 factors, 2x, x plus 4, and x minus 3. And everything only gets used once. So pick something. Either take the 2x and multiply it by x plus 4, or take the 2x and multiply it by x minus 3, but don't multiply it by both. And in fact, I'm going to suggest that we ignore that 2x for the moment and multiply the two binomials together. What you'll often find is this keeps our numbers smaller and is therefore a little bit easier to do. Just cleaning it up a little bit so that you can look back at this. Okay, so let's focus only on x plus 4 times x minus 3. But first, x times x is x squared. X times negative 3 is negative 3x. 4 times x is positive 4x, and positive 4 times negative 3 is negative 12. 2 terms times 2 terms gave us 1, 2, 3, 4 terms. That reminds us that we did multiply everything by everything else. We're almost ready to use the 2x, but I'm going to choose to clean up the terms in the brackets by collecting like terms. So we have x squared, and then notice that negative 3 plus 4 is plus 1x, or just plus x minus 12. At this point, it is absolutely okay to multiply everything by 2x, but again, I find it a little bit tidier if I can simplify as I go. So now we need to take the 2x, the monomial, and multiply it by every single term inside the brackets. So 2x times x squared is 2x cubed. 2x times x is 2x squared. And 2x times negative 12 is negative 24x. If you know how to factor, you know how to go right back to the beginning. So I'm going to remind you that we do want to simplify. When it says simplify, we want to stop here. We want a series of terms at the end. If you're tempted to factor, hold on to that thought until we get to the factoring module.